This is question 2 from homework, number 6. So for A, we're being asked the work that gravitational force does from point P to Q. And when something goes down, the work done by gravity is positive. So then recall that the work of gravity is mgh, where h is the change in height. So we know what P is. It's given to us. In my case, it's a 6R. And that we know what Q is. In my case, it's 1R. And we know what R is. It should be given to you. In my case, it's 12 centimeters, but you need to have it in meters. So we already know mass. We already know the constant of gravity. Those are given. Well, constant of gravity we should know is 9.8. So then for our height, we put in our change in height from 6R to 1R. In my case, it's 5R. So then we plug in the numbers that we know, our mass, our gravity, our R, and how many R there are, and you multiply them together, and that should give you A. And for B, it's a very similar process. They ask about the work from P to the top of the circle. Notice that the top of the circle is 2R away from the ground. That's because the top of the circle is the same as the diameter, and the diameter is just 2R. So you work for the exact same process, except the change is from 6R to 2R. So the change is 4R. R is just a radius. And then you just plug in the numbers. Everything else should be the same, and you get a slightly different answer. And then for C, they're asking us about the potential energy at the start. Or we'll assume point P is the start. It doesn't really matter. And we're assuming that at the ground, it's 0. Why? That's basically saying it's 0 at the bottom of the loop, which is 0 at the ground. Just different wording. So we have to use the same formula, mass times gravity times the height. But why? Well, this is because before we were calculating the change in energy. But the thing is, the change of energy from 0 is the same thing as 0. 5 is the same thing as the change of 0 to 5. It's also 5. So we can use the exact same formula. So we use mass times gravity times by the total height, which in my case is 6R. And that should give you a bigger number than A and B. A or B. Should be bigger than both. And then for D, we're being asked about the potential energy at a specific point, at point Q. So we could go through the same process and just use the change in R, but what I've decided to done, doesn't matter, you could do it a different way, is that we know the potential energy, all the energy in the system. That's C. We just solved that. And we know that the mechanical energy in the system stays constant. And this question is asking about point Q. And we already know the gravity, work done by gravity at point Q. So the work done by the gravity at point Q plus the potential energy has to equal the total potential energy, because mechanical energy is conserved. So you can just take your total joules, minus it from the number you got from part A, and that will give you D. And for E, it's the same process. You take your total potential energy, minus it in this case from B, gives you the remaining energy. That's because the change in work plus the potential energy equals the total potential energy, or the mechanical energy it's called. And the change in work is just kinetic energy. So that's how you tackle this.